Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, we're talking about the structure of the modern periodic table. Now, you all know the periodic table is hanging on the wall in your chemistry classroom. In my classroom, it's on the ceiling as well. I even have periodic table mugs. I love the periodic table. So let's talk a little bit about it. What you need to know about the periodic table is that the horizontal rows in the periodic table are called periods, and there are 7 of them. They're numbered 1 through 7. Now, I know there's 7 tables, and then we've got those blue and purple rows down at the bottom. They actually belong to periods 6 and 7. Glenn Seaborg said, hey, we can pull the lanthanides and actinides out and put them down below and have a more compact structure, but they really do belong to periods 6 and 7. The other thing I wanted to mention about the periods is that we have a regular pattern as we go from left to right across the period, where we have reactive metals to metalloids to nonmetals, and then finally gases that aren't reactive at all. So we have this pattern as we go from left to right. The vertical columns in the periodic table are referred to as groups, and sometimes you'll hear these referred to as families because the elements that are in the same group have similar properties. We'll talk about that in a separate webcast. Right now, I just wanted to introduce this idea of groups. Now, there's actually more than one way to determine which group you're in or identify that. So the first convention for numbering the columns is simply to number them from 1 to 18 from left to right. I've put some of the numbers in here. It was going to get a little crowded, so I didn't want to put in all 18, but you can figure that out. I'm not worried about that at all. I prefer this convention because it's so unambiguous. There is another convention that uses numerals. They could be our typical Arabic numerals or our Roman numerals, then with an A and B. So you might have 1A and 2A, and then 3A, and then 1B and 2B, and so on. It's all good. Really, what we're trying to focus on is that we can identify what group we're talking about. And remember, the elements in the same group have similar properties. We'll talk about that separately. Another thing I thought was worth mentioning is that the elements in groups 1 and 2 and 13 through 18 are referred to as the representative elements. Sometimes we just want to focus on these ones where we have very clear-cut patterns of change. They're also sometimes referred to as the main group elements, and since this term comes up a lot, I thought I should mention it to you. Now, there are a lot of other periodic tables. Here's one that it starts with a circular pattern, and then the transition metals sort of go off and do their thing. But you'll see, if you look carefully, that the noble gases are still all together. The alkali metals are still all together. The alkaline earth metals are still all together in the spokes of the wheel. So this is a different representation. Here's another representation of the periodic table based on the galaxy. So hydrogen and helium are in the center, and then all the other elements comes exploding out. And the idea behind this one is that hydrogen and helium in the sun or in the stars undergo fusion, and then all the other elements end up getting created from there. So that's interesting too. Just another way of thinking about it. And if you look closely, you can see that the noble gases are together and the halogens are together. The elements that are in the same column in the regular periodic table are here in the same arms of the spiral. Another periodic table, this one from the 1950s that was published in Life magazine. I just thought it was cool. It kind of has this spiral effect. And here's another one that's circular. Again, we're keeping elements that are in the same group together in the spokes here. All right, so things that behave similarly are with other elements that behave similarly. So we have lots of different representations. The block pattern that we have it all hanging in our room is not the only way to represent this or to make sense of the data. So as a summary, there's a regular and repeating pattern to the arrangement of the elements in the periodic table. The horizontal rows are called periods, and we see that pattern as we go from left to right. And the vertical columns are called families or groups, and they contain elements that behave similarly. This is a really good stopping point. Okay, we'll talk another time. I love the periodic table.